Hi guys, this is 3.4 for the properties of exponential functions, but most of them are actually already covered in a 3.1, so it's kind of review for you, okay? So the learning goal here is that you need to know the relationship between the function's behavior and the a value in the a b to the power of x, the exponential function, and the relationship between the function behavior and the b as well, okay? So those are the two main things, as well as your domain range x and y intercepts and the asymptote, or we call the equation of the asymptote. In this case, it's the horizontal asymptote, which is a flat line. It's not a vertical line in this case. So let's take a look at the lesson first. So the first thing is relationship between the function's behavior and the a and the y equals a times a b to the power of x. So how does the a change it? So let's take a look at the a and b first. Okay, so what I'm going to do is I'm going to graph y equals 2 to the power of x. So when I'm going to use the red for the y equals 2 to the power of x. So it goes up like this. And then goes down. So it looks like going up that way. And it never touches the x-axis, by the way. Okay, even though my graph looks like it's touching it, it never touches it. Now let's take a look at this one. If you take a look at it, it actually starts, or it has the y-intercept of 3. And then when it is 1, it becomes actually 3 times more. So 1, 2, 3, 4, 5, 6. It's right there. And then it's even higher because at 2, instead of at 4, we have to have at 12. So it's something like this. And then 0.5 becomes 1.5. 0.25 becomes somewhere there with the 0.75. So actually is looking like that. So in terms of the transformation, which will be covered in the next session, but in terms of the transformation, as you expected already, the a value actually stretches vertically, okay? So it stretches it vertically, at the same time it changes the y-intercept, okay? So your reference y-intercept is at 0, 1, and then the y-intercept changes by a factor of the a, assuming that there is no vertical translations, okay? So that's the key, okay, that is the key. And then if you take a look at this one, before we go, I'm just going to make a little a note on it. So this basically A is a vertical stretch or compression, right? Stretch or compression, which will be dealt again in the next session. And then also A times 0, 1 gives you your new y-intercept when there is no vertical translation. Okay. Now, then take a look at C and D. They actually work in the same way too. So this one I'm going to use green for y equals 0.5 2 to the power of x. Now, you already, I think, know what's going to happen. So instead of starting at 0, 1, it's going to start at 0, 5. Instead of being at 1, 2, which is the original point for the y equals 2 to the power of x, it will be 1, 1. And then 2, 2 as well, instead of 2, 4, because everything is now being halved. So it can really go lower in terms of the graphing here. But if you see it, the graph actually is flattened compared to the red, which is the y equals just regular 2 to the power of x. Okay. Now then, if it was the -3, this time I'm going to use gray. Okay, I'm going to use gray. This one actually flips it, right? This one flips it and then stretches vertically. So we already had the y equals 3, 2 to the power of x, and the b, as you can see it. And then we basically flip that along the x-axis. So that gives us the vertical, not the vertical, sorry, the reflection on the x-axis. So when the a is -3, your a value is -3. So your y-intercept is -3, right? It's 0, -3. And then instead of being at 1, 6, it will be at 1, -6, and then 2, -12 somewhere there, and then -1, -1.5, etc. So the graph looks like vertically stretched like this, but it's the other way around in terms of the look. Okay, So that's that. Now the conclusion is then when a is greater than 1, obviously a vertical stretch, right? Vertical stretch by a factor of a, right? If it is in between 1 and 0, it is vertical stretch. Oh, sorry, not stretch, compression. What am I saying? Compression by a factor of a as well. Now, when a is less than 0, so it's a negative, I'm only talking about a being negative. I don't care whether a is negative 100, a is negative 2, etc. As before in the transformation unit, which was the last unit, when a is a negative value, we just take the negative and see it separately, right? We don't combine the negative sign and the number and then say whether that is vertical stretch or not. So when a is being negative, it means that it is a reflection on the x-axis. So, okay, so that's actually quite simple. It's pretty much the same as last unit. So then let's take a look at the second page. So if you go to the second page, then it is the relationship between a function's behavior and the b, okay? So, oh, by the way, let's go back to that one for now, just to make sure a impacts or influences the y value, right? Y value of the function. And we knew that from the last unit. I just want to remind you guys of that one. So let's take a look at then the b. So this one also was covered in the 3.1 briefly, and now this time we'll just graph it and then double check. So I'm going to use red to graph the y equals 2 to the power of x, and then it becomes that and that. So the graph looks like this, right? The graph looks like this. Now then if you look at the b, which I'm going to draw in blue, this one has y equals 0.5x. So in this case, my b is 0.5, which is between 0 and then 1. So what happens is that when x equals 0, the y-intercept is still at 1. 0.5 to the 0 is 1, right? Then if it is at 1, it's at 0.5. If it is at 2, it's at 0.25. And if it is at negative 1, remember this, if it is at power of negative 1, using your calculator, you will actually get at 2, right? Or in this case, we can say it is 1 over 2 to the power of negative 1. So that becomes 2 over 1 to the power of 1, so which is 2. Using same logic, when at x equals negative 2, it's at 4. So now the graph looks like that. Okay, so if you can see it, the b being greater than 1 actually gives the increasing function as the x value goes up, right? So if you can see it, as x value increases, the red graph is going up, whereas the blue graph, where the b value is in between 0 and negative 0 and 1, is actually decreasing. Okay, so we're going to take a note and a conclusion there. Okay. Now, then let's take a look at the next one. So we talked about in the last section or last page that a being greater than 1, a being between 0 and 1, and a being less than 0, right? So we will do the same thing. We talked about b being greater than 1, b being in between 0 and 1, and this time b being a less than 0. So it's a negative 2 in this case. So if you take a look at it, I'm going to create a table of values so that it's easier for you to see it. So x and y, let's say x was negative 2, so it's 2 to the power of negative 2, that is actually 1 over 4. Now 2 to the power of, negative 2 to the power of negative 1 gives me negative 1 over 2, right? Because negative 2 to the power of negative 1, well, negative does change it as a 1 over negative 2 to the power of 1, right? But I still have negative 2, so it should be negative 1 over 2. 0 gives me 1, 1 gives me negative 1 over 2, no, negative 2, negative 2. And then if I have 2, then it becomes 4, right? Because if you have negative 2 to the power of 2, which is a square, that gives me 4. So if I graph this, then 0 at 1, negative 2 at 1 over 4, and then negative 1 at negative half, 1 at negative 2, and 2 at 4. So if you kind of see it, the behavior of this graph then becomes like that. Is this a exponential function? No, this is not, right? This is not an exponential function. So as we talked about it already in a 3.1, in order for you to have the exponential function, the base, must be greater than 0, okay? So let's then go to the conclusion of it. So in the conclusion of it, b is being greater than 1. That basically tells you that it's an increasing function, okay? Increasing function. Now, without any of the transformations for now, okay? Without any of the transformations for now. Now, then b being in between 1 and 0, that means that it's a decreasing function. And then b being less than 0, it's not even a exponential function. We call this harmonic function, but you don't have to worry about that one, exponential function. You don't have to worry about the harmonic function until the first year calculus, okay? Maybe the second year. Now, then one thing that I really want you to be careful of is that y equals negative 2 to the power of x versus y equals negative 2 to the power of x, the negative 2 being the whole inside of the brackets. If you create a table of values for the first one in a red, I have x and y, negative 2, negative 1, 0, 1, 2. This actually gives me negative 4, sorry, negative 1 over 4, and then it will be negative 1 over 2, 1, it will be negative 2, and then it will be negative 4, okay? And the thing that you have to be careful of is that the negative sign here is not part of the power per se, okay? If I rewrite this, this should be written in this way if you're confused. The negative sign should be sitting outside, okay? That's why every value should be a negative. Whereas this one is changing, and that's because the negative sign is affected by the power, right? Here the negative sign is outside, so it's not affected by the power, whereas this negative sign is inside of the bracket, so it is affected by the power. So if I have, let's say, negative 1, 0, 1, and 2, I'll just go with a negative 1 for now. It gives me negative 1 over 2, and then it gives me 1, it gives me negative 2, it gives me 4. So the points are going like that instead of going that or that. So the behavior doesn't follow the exponential function, so they are not the same, okay? So be really careful of it. Be really careful of it. If you'd like to draw these two here and then bring it to me and get it checked, I will do that as well, okay? Now, then let's get to the last page of the day. I will try to finish this in about 2-3 minutes, okay? Because it actually is quite simple. For the exponential function, your domain is always x such that x is an element of real number. Okay, that's always the case. There's no restrictions to the domain of an exponential function. However, the range actually differs. So let's say I have y equals a, b, and then c to the power of x minus d plus, I don't know, I'll say k at the end. Okay, somehow I just don't use all the letters, but it's okay. Letters don't really mean much. You can use different letters anyway. So your range is always y is greater, or y such that y is greater than, not equal to, greater than k if a is greater than 1, and then such that y is all real numbers. Or y such that y is less than k if a, here actually a should be greater than 0, a is less than 0. So I'll just put it, a is less than 0, and y equals, or y is an element of real number. Now the reason is the k is actually the equation of the asymptote, where that flat, the function becomes very flat but never touches. And if you have a being greater than 0, the graph actually looks like that, and it never touches below that, right? So that's why your y value is always greater than that. Whereas the other one, if a is less than 0, then the graph goes always this way, if reflected, right? Or go that way, reflected this way, or reflected that way. So this is the k value that it never crosses, okay? So that's why. Now the x-intercept is never, okay? So it does not exist without any transformations. Now this changes, okay? This changes because when there's a transformation, you have to solve for the x by putting 0 into the y. So we're gonna do a bit of practice later on this, but you will actually figure this out really, really easily. Now the y-intercept is always 0, comma, a. Now it changes, okay? It also changes. This one changes depending on your k value. So in a more truthful way, it is actually 0, comma, a plus k. Okay. Now the equation of the asymptote is basically y equals k all the time. So let's take a look at the first example. I know it looks complicated or confusing, but when you actually get to do the examples or the questions in the textbook, you actually get it quite quickly. So the y equals 2 to the power of x, the domain is basically x such that x is an element of real number. Now the range, now there is no transformation. The a value, the value sitting in front of the 2 is actually 1. So y is greater than, now there is no k value, right? There is no k value, meaning k is 0. And then y is an element of real number. Now we're okay. Now then the x-intercepts, so x-intercept, no x-intercept. Now y-intercept is then 0, comma 1 as the y-intercept. And then for the equation of the asymptote, EOA, I will say, then it is y equals 0. Now some of you may question why is x-intercept none? Well, take a look at this. If you have 0 into the y, it will be 0 equals 2 to the power of x. Now the reason why I put the 0 into the y is because your x-intercept always has 0 for the y value. Now you try to solve for the x. Now there is no x value that actually makes 2 to the power of x 0, right? And that's why it is no. Are we okay? We're okay. Now then let's take a look at this one. So same, our domain is x as an element of real number, right? It's always, always, always that. So it's kind of freebie for you if you see this on the quiz or the test. Now then the y such that y, now you have negative 2 in front of, or sorry, negative 1 in front of the 2, not included in the 2 and the power of x. So is less than 0 because k value is 0 because there's no value at all. And then y is an element of real number. Now then the x-intercept, again, there is none. And then y-intercept is now 0, comma. I told you the y-intercept is 0, comma a plus k. There is negative 1, so there you go. Okay. Now the equation of the asymptote is basically still y equals k, but there's no k, so y equals 0. Okay. And same thing for these. So I'm just going to go quite quickly on these. And then EOA. So we have domain x such that x as an element of real number. And then y is less than 0 because my a value is negative 1. Now, comma, y is an element of real number. Now, x-intercept does not exist, none. Now, then y-intercept is 0, comma, negative 1 as well, because the a value is negative 1. K is 0 for now, right? There is no k at the end. So the equation of the axes, or equation of the asymptote, is y equals 0. Okay. Now, then something more, a little complicated. So the domain range x-intercept, y-intercept, and then equation of the asymptote. Now I want you to actually try this on this one on your own. I will put the solution of this on the Facebook, okay? So let's do that a little later. Now, then how to write an exponential equation by looking at it without any horizontal or vertical translations, okay? Meaning you just need to find the a value. That's all I'm asking. Just the a value and the b value. That's all that is. So let's assume that we don't have this. Let's assume that we just have the graph. So all you have to do is this. Take a look at the y-intercept. The y-intercept tells you the a value, right? The y-intercept tells you a value. So y equals 1, b to the power of x. So set it up like this. If it was sitting at 4, then obviously a is 4. Then choose a point. Choose an easy point for you to work with. So in this case, I would choose this one. Don't choose obviously the y-intercept. It's not going to actually do any good for you because you already used it. So I'm going to use -1 comma 2. So 2 equals 1, well not there, b to the power of -2. Now this means that 2 and then 1 over b squared. Do you agree? Because the negative part becomes 1 over b. So this becomes 1 over b squared equals 2. Now you're solving for b squared, so all you have to do is b squared equals 1 over 2. So then b is square root of 1 over 2 and then plus minus in the front. However, I told you that b will never be negative, so it should be just a positive 1 over square root of 1 over 2. Are we okay? Okay. So then this becomes of x. Oh, something. Oh, sorry. I made a mistake. It was 1. I made a mistake. It was at -1 comma 2, right? It was at -1 comma 2. So x is supposed to be at -1. So it should be just that. I actually made it overcomplicated then. So b is then 1 over 2. So it will say y equals 1 over 2 to the power of x. So it was my mistake, my apology. It was supposed to be at -1 comma 2 instead of -2 comma 2 since I chose this point right there. So hopefully it was okay. I will see you guys in class, okay? Bye.